Okay, good afternoon, everyone. My name is Saurav. I work for the ONF, and that stands for the Open Networking Foundation. And I'm here to talk about how ONF builds on top of OCP products for the telco world and the cableco world, especially in the areas of broadband access. Okay, so first, a little bit about the organization I work for. The Open Networking Foundation is a vibrant operator-led consortium. We have 160 members. At the very top of our membership tier is the operators. We have several of them, and they are the ones who guide the direction of the open source projects that we work on. There's about 10 projects that we work on, and once they set the direction, what we call it curated open source. Once they set the direction for our projects, our engineering team, the ONF has a 25-person strong engineering team, and these people work with our vendor partners and other operators and other partners and collaborators like the Open Compute Project to deliver on these various software platforms. So I will be talking about a few of them today, but this is what it looks like. Our umbrella project, what we call is known as CORD, or Central Office Re-architected as a Data Center. And the basic idea behind it is that telco operators or cable operators, they have various different kinds of subscribers, customers, end users. They could be the mobile ones, they could be business subscribers, they could be residential subscribers. The point is that all of this different kinds of traffic in the past have been supported by different chains of equipment, right? And each chain of equipment has equipment management systems for each equipment in that chain. And so as a result, you will find that these central offices today are very, very complicated. They have a lot of equipment in there, a lot of different ways to manage it. And it's a real CapEx and OpEx burden on the service providers. So the idea behind CORD is, what if we could keep the same subscribers, but then move all of the services to off-the-shelf hardware and open source software, right? So basically do for the telco operators what the Web 2.0 companies have done in their operations. So bring in the economies of a data center as well as the agility of a cloud provider to the telco central office. So this is a look at all of our projects, and what we do is really take collections of these projects into solutions that are then deployable by the telco operator. So the telco operator, the operators in our partnership, they set the direction for these solutions. SEBA is one of them, Trellis or NFV Fabric is another one, and there are other projects for the mobile space. But today at this conference, I'm going to be talking about a couple of our projects, a couple of our solutions, again set by the operator, the direction for which was set by the operator. So first of all, I'm going to talk about an optical line terminal, okay, for residential broadband access. So this is a typical chassis-based vendor OLT for passive optical networks that are used in fiber to the home deployments. Now, this box, if you really see what's inside, okay, there is the head end part, the optical part, the MAC blades that are part of this chassis. There's also compute blades where all the software runs. That software brings out features in the PON. And there's typically a backplane that connects together all of these line cards, the compute blades as well as the PON MAC blades. And of course, there's probably an element management system that is managing this box. So the first step for SDNizing this is, okay, well, what if we could just consider as pizza boxes the PON MAC blades, right? They could be independent pizza box based, just like data center switches. You could also have a PON MAC blade where each of the port is not an Ethernet port, but it's a PON port, right? Each port on that box actually leads to an optical distribution network that goes to boxes that are at the end user's homes. right? So each port over there can support up to 64 or 128 subscribers. And then the second part of SDNization is to manage this box from outside the box, right? So Volta is a software that is a project at the ONF, and it's meant for becoming a virtual OLT hardware abstraction. Okay, so what Volta does is not only does it manage the OLT and the ONU, but it also presents the entire PON as a pseudo Ethernet switch to the SDN controller. So the SDN controller doesn't actually see the low-level details of the PON. It doesn't see that there is PLO messaging going on between the OLT and ONU. It doesn't see that there is OMCI messaging going on between the OLT and ONU. What it really sees is an Ethernet in and Ethernet out, okay? And the SDN controller knows how to bring out features from that box. So it's two levels of abstraction that is going through this. So together, we get the Open Compute project where operators are submitting specifications. AT&T has one for a 10 gig symmetric PON. Deutsche Telekom has another one for a GPON box. And then we write, at ONF, we write the software together with the community that manages these box. So if you understand this OLT disaggregation, and then we can see the system that we build around this. So as I was saying before, this is the residential access network, the fiber distribution network, and let's see if I can get my cursor over here. So here's the fiber distribution network going to the ONUs that either are at the homes or maybe even at a mobile base station or maybe at an enterprise customer, right? So while it says fiber to the home, it can actually support many other kinds of subscribers, and telcos are very interested in doing that. So this fiber distribution network at the head end is this OLT box that is OCP accepted. This one we use is from EdgeCore. So a SEBA pod, when SEBA stands for SDN Enabled Broadband Access, such a SEBA pod can actually support 16 of these OLT boxes. And each box can support 1,000 or more subscribers. So a full SEBA pod is actually designed to support 16 to 18,000 subscribers. Okay, and as I mentioned before, upstream from this box, we typically have a couple of top-of-rack switches. Their main job is to aggregate the traffic from the OLT and send it on to an external BNG, and then disaggregate the traffic towards the respective OLT and the respective subscriber on the way back. Okay, and to these top-of-rack switches, we also connect our compute nodes. So both the top-of-rack switches as well as the compute nodes, they come from OCP accepted or OCP inspired solutions. But it is in these compute nodes where we actually have all of our SDN software, right? So the software stack that I had shown before, where Volta is the abstraction for the access network, that then presents the access network as a switch, just like a real switch. Just like a real switch, the Volta presents the whole PON as an abstraction to the SDN controller. So the SDN controller brings out all the features in the PON as well as the access devices, right? And then on top of that, we have another functional block that we call a network edge mediator. Its job is to not just orchestrate inside this pod and monitor what's going on inside the pod in terms of FCAPS capabilities, but also to work with different network operators' backends, the OSS, BSS systems. So all of our software that you see within the dashed line, within the SEBA pod, it's roughly about 40 to 50 containers. These are Docker containers that are managed using Kubernetes and installed on the servers using standard Helm charts. So it's a fully containerized solution that we deploy on the physical servers that you see inside the pod. Okay, so to give you a little bit more idea about what we mean by white boxes or this generic hardware that we get from the OCP, our definition of a white box is not just that the hardware has to be open spec, for example, what we are getting from the OCP, but also open source software on top of it, right? If you don't have open hardware and open source software, what you have then is what some people call a gray box or a bright box. And then if neither of them are open, of course, then it becomes a black box. But what we work with in SEBA is a white box with open hardware specs from OCP. The one you see over here was submitted by AT&T. There's a similar one. And AT&T was done for XGS-PON, which is 10 gigabit symmetric PON. There is another one from Deutsche Telekom that is now coming for GPON, which is the gigabit version of fiber to the home networks. And then the software that we write on top of it is the same, whether it's XGS-PON or GPON. And in the future, it'll be for GE-PON as well. The software, as you can see, ONL and ONIE, they come from OCP. The chip, it could be an FPGA. Today, it is actually silicon that comes from Broadcom. So the SDKs are usually closed source, but there is the chip driver called BAL, or Broadband Adaptation Layer, that also comes from Broadcom that supports open APIs. So because this supports open APIs, we can write open source software on top of it. So everything above this now in the stack that I show you is completely open source, and it comes from the ONF. So white box is open specs plus open source software. And this is true not just for the OLT, that is the head end of the PON, but also, like I'd shown before, all these OLTs aggregate into top-of-rack switches. So again, the top-of-rack switches, the specs for it are open accepted, comes from the OCP, and the software that runs it also comes from the ONF, right? Again, we have ONN and ONIE, and again, an ASIC and an SDK on top of it that is closed source. But then we use software from Broadcom called OFDPA, which essentially exposes open APIs. And so then everything above it is open source. So to give you an idea of what OFDPA looks like, basically it's a pipeline abstraction. Just like a few slides before, I was showing Volta, which was a PON abstraction. It made the whole passive optical network appear to be an Ethernet in, Ethernet out switch. Similarly, OFDPA is a pipeline abstraction. So OFDPA says that in a top-of-rack switching ASIC, this is what the pipeline looks like, right? This is the bridging table, this is the routing table, this is the MPLS table, this is how you do ECMP, so on and so forth. It's a pipeline abstraction, but under the hood, there's actually multiple different kinds of silicon in there, Trident 2, Tomahawk, the Qumran-based switches, that actually have different pipelines. So what this abstraction does is tells you that, hey, don't worry about the differences between the different kinds of silicon that comes from Broadcom, okay? You just have to worry about what this pipeline looks like because it's an abstraction, and that's what the controller programs, right? And under the hood, Broadcom takes care of the differences between the pipelines. So these are the two abstractions that I was telling you. OFDPA actually runs on the top of rack switches. Volta runs outside the box, but they are both abstraction. One for the top of rack switching, one for the access network, the residential access network. And then they are both managed by this SDN controller, which brings out all these features. So for example, this is how it would work. Volta reaches out to the physical OLT, okay, and it discovers the OLT's particular ports that it exposes as a logical switch to the SDN controller. Then as these residential boxes are discovered by these head-end box, the ONUs are discovered by the OLT. Each ONU is again represented as a logical port on the logical switch. And this is what gets shown to the SDN controller. As more ONUs are discovered, there are more ports that show up on that particular logical switch. And then on top of the SDN controller, we can implement all of these features on the PON, just like we implement features on the top of rack switch. OK, so that's SEBA. This is what SEBA looked like. And in SEBA, we use a couple of top of rack switches. But those leaf switches are actually expandable to an entire fabric, right? It can actually become an entire leaf spine fabric that, again, supports local compute, has different access equipment connected to it, upstream routers connected to it. And you can also have the choice of taking this deeper into the network, even closer to the end user, and have the access equipment be connected over there. Okay, so this project, again, as I said, it's SDN controlled with a lot of features. We actually call it Trellis, and we work with Comcast very closely on productizing Trellis. And so it's in production trials at Comcast right now. So this is my last slide. I just wanted to say, if you're interested in these projects, the way to get involved, SEBA, we have a lot of data on our wikis, on our guides. Similarly, Volta, the abstraction for the residential access network. We have community information everywhere. Trellis is the leaf spine fabric. Again, that's, and of course, the OCP Telco openEDGE workgroup, which is, there's a lot of important information on the wiki and the mailing list as well. So thank you very much, Craig and Sumitra, for inviting me here. Any questions? Okay, thank you very much.